part one of our discussion this morning. Let's have the heat versus temperature lesson, the first topic under thermodynamics. So let's have a short trivia first. Did you know the hottest recorded temperature in the Philippines was recorded in Tuguegarao City, in which the recorded temperature, the heat index, okay, the heat index is umabot siya ng 42.2 degrees Celsius or equivalent to 107.96 degree Fahrenheit. Again, that's the reported heat index. So again, it was recorded in Tuguegarao City in the province of Cagayan. That was the hottest recorded temperature. It was recorded in Tuguegarao. How about the kung natin hottest, how about the coldest temperature? Saang city? Saang city usually nakaka-experience ang mga tao ng coldest temperature so far? Okay, very good, no? Sa Baguio City. Especially the month of February. Okay, bugnaw ang temperature sa Baguio karon for the month of February. It's because that's the time na nag-melt ang ice, no? So, pag mag-melt ang ice, mapalit sa hangin. I forgot the term, but mapalit sa hangin. Yeah, that's the time kasi nag-melt na ang ice karon sa North Pole. So, yung hangin daw, yung wind breeze, yung kabugnaw sa hangin is papunta sa Baguio. That makes Baguio experience in the coldest temperature so far. So, however, worldwide, the hottest temperature on Earth was recorded at 134 degrees Fahrenheit or 56.7 degrees Celsius at Greenland Grants Death Valley. It was in California.
So yun. Of course naman, I think the coldest one or the coldest area naman siguro is located either in North Pole or the South Pole. So bugno, sa Earth mismo. Now, why are there different scales to measure temperature and which one is the most accurate? So let us answer these questions in the lesson that follows. So it will be, these questions will be answered later about the topic heat versus temperature. So what are the learning objectives this morning? At the end of the lesson, you will be able to first differentiate heat and temperature. Second, explain the different definitions of temperature. Also, distinguish between distinguish among Celsius, Fahrenheit, and Kelvin scales. That's the different way on reporting the temperature. And lastly, solve problems related to the conversion of temperature from one scale to another. So I think the solving part is not that difficult because you have experience already converting degrees Celsius to Fahrenheit, Fahrenheit to Celsius, or vice versa, no? Including the Kelvin when you were in high school. So yeah, i-discuss ko rin siya dito. Okay, wait lang ha. Naku, file. Na-live na ba to? Wait lang ha. Okay, na-live na di ay. Okay, sige. Let's start. Let's start with the definition of thermodynamics. So again, our discussion today is the first subtopic under thermodynamics. So when we say thermodynamics, this is one of the key branches of science and engineering and it deals with a systematic study of systems' thermal or internal energy. So in this lesson, we will unlock the similarities and differences between the two main concepts of thermodynamics, which is the temperature and heat. Ano nga ba yung kaibahan? Ano nga ba yung kaibahan ng temperature at saka ng heat? Typically, when you heard the word temperature and heat, somehow no, they are similar in nature. No, again, they are similar in nature, but they have differences. Again, temperature and heat are the two main concepts under thermodynamics. If you can still recall, no, one of the 7 SI unit, remember mo, no? One of the 7 SI unit is temperature. Again, one of the 7 SI unit is temperature, and the base unit for temperature is Kelvin. If naka-remember mo sa tuang lesson last semester. So, aside from the temperature is considered as one of the SI unit, also temperature, it is defined as the degree of coldness and warmth. Coldness and warmness. I mean, coldness or warmth of an environment or an object relative to a specified standard value. It is a measure of the average kinetic energy of the particles in an object or environment, and it is measured either in degrees or units assigned on a standard scale. It depends, no? Like units in Celsius, in Kelvin, or in Fahrenheit. Now, temperature also is the capacity to transfer heat from one system to another. Again, temperature is the measure of the capacity to transfer heat from one system to another. An object or environment is hot when temperature is high. Kung cold naman, when the temperature is low. Lain pong kayo, no? Kung init kaayo ang temperature, bugnaw di ay, di ba? It's very humid, di ba? Once very humid yung temperature, very init masyado, no? Of course, pag bugnaw ang temperature, of course, I mean, kung bugnaw ang panahon, that means the temperature is low. Just like in our classroom, pag baba ang ano ng aircon, di ba? The temperature is very low. Kung bugnaw ang ano ko, pero kung igang naman kayo sa classroom, temperature is high. Now, as you can see in the given figure, dyan, may dalawang figure dyan, ha? Okay? These two figure over there sa ano natin sa slide, okay? That is the basis, no? Maybe deceiving if not altogether in price. So these are instruments for the measurement of temperature. Again, the two are the measurement of temperature. We have here, as you can see, you are familiar with this one. Yung ginagamit natin pag may fever kayo, no? That's the common one. Is a thermometer. I mean, a mercury in glass. Okay, thermometer is technically a mercury in glass. Diba? Try to I think you have nakita naman siguro mo thermometer, no? So yung color red dyan, that's the mercury, no? Mercury in glass. Yung that's the reason why bakit kung kalinturahon mo mutaas, di ba? The other one naman, that is a volume container. It's for the pressure. Okay, it measures the pressure. So by having like this, no, like as the gas increases, or if the pressure increases, what happened to the gas? Okay? If the temperature will decrease, what happened to the gas pressure? Ganon. So we have this one. Again, it's a mercury in glass. Then yung kabila naman is a constant volume container. So yung, I think familiar naman mo anong mercury in glass. Same with the constant volume container. Kada kung oxygen ba, oxygen, kung makita mo sa hospital or any, depende. Wala lang man sa hospital, naman po na siya sa mga any shop ay mga oxygen dira. So the mercury in glass, it changes in temperature. Changes in temperature cause the liquid's volume to change. Kung mag-init gani ang, di ba, kung kalinturahon mo, mag-increase to yung red, di ba, yung liquid mercury. Yung mercury rather. Okay, mag-increase yung mercury pag mag-init ang temperature. Just like kung meron kayong fever. Meanwhile, in the constant volume container, it changes in temperature causes the liquid's volume to change. Okay? In this situation also, if the liquid's volume will change, of course, the pressure also will change. Okay? Again, the pressure also will change. Take note of the formula of pressure. We have density of the fluid times the volume, if you can still recall, times the acceleration due to gravity. So, note of this one. Mercury in glass, yung sa thermometer, example thermometer, as the system gets hotter, the colored mercury or ethanol inside expands and goes up in the thermometer tube. And for the constant volume container, a gauge measures the pressure as the gas increases or decreases temperature. Now, let's proceed to heat. When we say heat, it refers to the energy that is transferred spontaneously from system to its environment through a process other than through the transfer of matter or through work. Again, heat refers to the energy that is transferred spontaneously from a system to its environment through a process other than through the transfer of matter or work. Of course, take note of this one. Heat will flow from a hotter to a colder object when the pathway has a suitable conditions for a transfer. Again, the heat will flow from hotter to colder object when the pathway has suitable conditions for the transfer. Next, we have the temperature scales. There are three, okay? There are three temperature scales. We have Celsius, Fahrenheit, and Kelvin. The SI unit for temperature is Kelvin. Okay, hindi Celsius and Fahrenheit, but it's Kelvin. Now, scales in devices that measures temperature, we have three. We have the Fahrenheit, the Celsius, and temperature, and it must be indicated on the wall of the tube to quantify temperature. Kung makakita mo thermometer, may nakalagay, no? Sa thermometer class, duha lang kabuok ako makita dito na scale. The Fahrenheit at saka the Celsius. Okay? Again, sa thermometer namo sa moong balay, ang ako lang makita doon is the scale na Celsius at saka Fahrenheit. So if the liquid level of the thermometer will be marked 0, for which the water will freeze, and 0 and 100 for which it will boil, the distance between 0 and 100 will be divided into degrees or 100, and that's the time we can obtain a Celsius temperature scale. Any state with a temperature lower than freezing water will have a negative value. So in both Celsius and Fahrenheit, there is a negative value. Again, there is a negative value for Celsius and Fahrenheit. Meanwhile, for Kelvin, there's no such negative Kelvin because the minimum value for Kelvin is 0. Again, the minimum value for Kelvin is 0. For Fahrenheit temperature scale, accounting for standard atmospheric pressure, where the temperature of freezing water is 32 degrees and the boiling point of water is 212, that's the Fahrenheit temperature scale. So actually, class, the formula, no, yan, as you can see, to convert temperature in Celsius, okay, to convert this one, example tayo, if given yung Fahrenheit, again na, this formula will be used if the given is Fahrenheit and you are going to convert that one into degrees Celsius. Again, this formula will be used if the degree of Fahrenheit, if the given is Fahrenheit, and that will be converted into Celsius. Meanwhile, this formula on the other hand will be used ito, if the given is Celsius, then i-convert mo siya into Fahrenheit. Again, ito, if the given is Fahrenheit, i-convert into Celsius mo yung formula. Meanwhile, ito naman na formula, okay, this will be used if the given is Celsius and you are going to convert that one into Fahrenheit. Okay? Now, kindly check the graph. Tanaw ang graph as. Ba, namin lang kita na point of intersection. So, ang point of intersection dira class kanang -40 and -40. Tanawa. The red one is the, wait lang, let me analyze, no? Yeah, the red one is the Celsius and the blue one is the Fahrenheit. Yes. If you can see in the graph, no, presented in the presentation, that intersection, that's that intersection, makita ninyo, that's the time mag-equal ang value ni Celsius of the temperature. Again, please take note. Para makita niyo dira class, yung -40. If -40 daw ang temperature ng Celsius, the converted Fahrenheit is also -40. So, that's the time, that's the numerical value na magka-equal ang temperature ng Celsius at saka Fahrenheit. Again, that's the time ma-equal ang value ni temperature na Celsius at saka ni Fahrenheit. It's in -40. So in converting Celsius to Fahrenheit, a temperature in Celsius will be the value of Celsius degrees above the freezing point. And the value of Fahrenheit degrees beyond the freezing is 9/5 of it. How about Kelvin scale? Okay, one of the scale is Kelvin, and that is the SI unit for temperature. Yan. So observe that in a constant volume of gas thermometer, okay, tanaw dira, the gas pressure increases with the temperature when its volume is held constant. Again, observe that in a constant volume gas thermometer, the gas pressure increases with the temperature when its volume is held constant. In this graph class, a hypothetical temperature is equal to negative 217.15 degrees Celsius makes the absolute pressure of the fluid, as with the various other gases, to be zero. This zero pressure temperature is the basis for the Kelvin temperature scale. That is why the formula for Kelvin, if you can still, remember ninyo, the formula of Kelvin class, it's the temperature in Celsius, okay? It's the temperature in Celsius plus 273.15. Okay? To convert Celsius to Kelvin, again, to convert Celsius to Kelvin, this is the formula. Yan. Mag-add ka ng 273.15. So this zero pressure temperature is the basis for the Kelvin temperature, and the units of Kelvin scale are the same as those from the Celsius scale. However, 0 Kelvin is equivalent to negative 273.15 degrees Celsius, and 273.15 Kelvin is equal to 0 degree Celsius. That makes the formula to have like this. And this is the formula. Next, the Kelvin temperature scale is also referred to as the absolute temperature scale, and its 0 point is called absolute zero. The 0 Kelvin means it doesn't have a temperature at all. Again, the 0 Kelvin means it doesn't have a temperature. However, the 0 degree Celsius at saka the 0 degree Fahrenheit, hindi ibig sabihin niya na wala silang temperature. Again, try to differentiate this one, ha? Ang 0 degree Kelvin, ibig sabihin yan, that's the absence. That's the absence of temperature already. However, in degrees Celsius, 0 degrees Celsius at saka 0 degree Fahrenheit, ang ibig sabihin yan, class, okay? The temperature is still present, okay? Hindi ibig sabihin na 0 degrees Celsius wala ng temperature. Ibig sabihin yan, the temperature is still there, but it is just a numerical representation, no? It is just a numerical representation only, because the only value na absent yung temperature is 0 degree Kelvin. And 0 degree Kelvin is equivalent to negative 273.15 degrees Celsius. Okay? Yan yung sinabi kanina, no? Take note of this one. 0 Kelvin is equal to negative 273.15 degrees Celsius. And 0 degrees Celsius is equal to 273.15 degree Kelvin. Because take note of the formula, to convert Celsius to Kelvin, the formula is 0 degrees Celsius plus 273.15. Okay? Again, ha? Ang ibig sabihin ng 0 degree Celsius at saka 0 degree Fahrenheit, meron pang temperature, okay? The temperature is present. It is just a numerical representation. It's either pag 0 degree Celsius, I think that's freezing point ba? Let me check daw be the freezing point if mali ko. Yeah, that 0 degrees Celsius is just a freezing point. Ibig sabihin, there's still a temperature. Bugnaw. But 0 degree Kelvin is, yeah, that's the absence of temperature already. Walay temperature, that's the absence of temperature already. At this moment, let's convert this one. Again, convert 101 degrees Celsius to Fahrenheit. So the given is Celsius. Then, kailangan natin siya convert into Fahrenheit. Ay, wait, baliktad akong degree. Sige, what's the formula? If you can still recall. Again, what's the formula? So, we are going to use this formula. Ano man? Is this correct? Wait, nakulangan. 1.8. Actually, class 9/5 is the same as 1.8. Okay? 9/5 is the same as 1.8. So let's try to convert. Yan. So 1.8 times 101 degrees Celsius. Wait lang. Eraser. No, di na mag-click. Plus 32 degrees. Ilan answer? Okay, 213.8. But ayaw kalimot, degree Fahrenheit. Final answer, apply sig fig. Apply sig fig. You have 214 degree Fahrenheit. Of course, do not forget to put degree Fahrenheit. Okay? To differentiate that your answer is not degree Celsius, not also Kelvin. Okay? Now, let's proceed to our second example. And the first example, no? Second example. This one. Again, this one, that's the answer. This is the solution. How about this one? Convert and Kelvin to Celsius. So take note of the formula of Kelvin. Ito yung formula ng Kelvin, ha? Yan. This is the formula of Kelvin. So you can manipulate the formula again, ha? Pwede na ninyo ma-manipulate ang formula. Okay, I want you to solve. Let's solve. So if we are going to write the given, no? Our given, di ba, it's 10 Kelvin. So we have here, it's 10. So degrees Celsius man yung missing. So i-minus lang, actually, i-minus lang. 10 minus 273.15. Yan. So the answer is negative 263.15. Final answer, it's negative 263. Yan, that's the answer. Okay, negative 263. Hoy, i-manipulate lang mana. Okay, i-manipulate lang ninyo. This is the original formula. The Kelvin is given. You are going to solve for the Celsius. So just manipulate the formula. Question. Ano na ba itong mag 264? Naunsa di ka ba mag-round off? Next. This one. You have left a can of soda in the freezer until it reached a temperature drop of 10 Kelvin. This time, determine the temperature change the soda in degree Fahrenheit. Again, you have left a can of soda in the freezer until it reached a temperature drop of 10 degree Kelvin. Determine the temperature change in the soda. So actually, class, this solving, yan, medyo iba siya, no? Iba ito na solving class. Hindi siya directly na yung formula ng Kelvin ang ating gagamitin to convert into Fahrenheit. Yes, hindi ganyan ang gagamitin natin. Kasi it was being mentioned here, you have left a can of soda in the freezer until it reached a temperature drop to 10 Kelvin. So there is a change of temperature. Again, there is a change of temperature in Kelvin. So the question also here, determine the temperature change in the soda. So we are going to solve also the temperature change in the soda in terms of degree Fahrenheit. So sir, asa man pag-solve? Asa man na sir, pag-solve ng mga temperature change. Don't you worry, I will derive the formula for you, but let me present now how to derive the formula. Again, let me present first how to derive the formula. Originally, the formula of Kelvin is, sige, itong formula ng Kelvin, degree Celsius plus 273.15. Tama? That's the formula of Kelvin. And the formula of Celsius to Fahrenheit, we have 0 degrees Celsius, 5/9 rather, times degree Fahrenheit minus 32. Yan. So based on these formula dito, no? Yes. Ang gagawin natin, class, ang value nito, itong value ng ating degree Celsius, we are going to substitute that one dito. Okay? Ang value natin nito, is-substitute natin siya dyan. So magiging 5/9 degree Fahrenheit. Sorry, parenthesis pala, I forgot. Yan. Minus 32 plus 273.15. Na mga nagat-chat ba pero late ilahang oras? Yeah, I don't know. That's the reason why nganong na ay i-check good inyong chat box, no? I-check inyong oras sa inyong chat box, diba lahi sa kong oras diri. Anyway, after this one, okay? Ito na ha, again, ito na yun siya. Gi-substitute lang natin. Now, when we say temperature change, anong change in temperature o temperature change? Ka-remember mo itong concept na to sa change in velocity. Let's try no to recall change in velocity. When we say change in velocity, this is velocity 2 minus velocity 1. Tama? Ka-recall mo? Again, change in velocity means velocity 2 minus velocity 1. So in this situation, the change in temperature, again, the change in temperature also, we have here, it's just the same idea or concept with this one. So it's just the change of Kelvin 2 minus Kelvin 1. Again, the change in temperature is Kelvin 2 minus Kelvin 1, diba? So dito, let's have a label na this is Kelvin 2. And this is degree Fahrenheit 2. Yan. Plus 273.15. The other one naman is Kelvin 1. Same pa rin. 5/9. Pero degree Fahrenheit 1. Yan. Again, when we say change, di ba? It's the difference. The difference between temperature change means the difference between two temperature. So class, kung i-minus ni mo ni, yan, kung i-minus ni mo na siya, Kelvin 2 minus Kelvin 1, that is what we call temperature change in Kelvin. Again, Kelvin 2 minus Kelvin 1, that is temperature change in Kelvin. Then 5/9, then Fahrenheit 2 minus Fahrenheit 1. And that is the change of Kelvin is equal to 5/9 the change in Fahrenheit. Sir, what happened? What happened to 32 at saka ito? Sige daw, be. What happened? Pag i-minus niyo mo ni siya, minus this one, what's the answer? Di ba 0? Di ba 0, no? Pag i-minus. Kung ang 32 po di mo class kani, okay, applying the proper way, no, like i-distribute, using distributive property. So, of course, kung i-distribute niyo mo sila, ilang kaya ang 5/9 times 32? Yeah, that's 17.78. Wait lang kay murag pangit diri ibutang. Kana siya class, kung i-distribute ninyo class, the answer is 17.78. So pag i-minus po di mo na siya diri pod, kani pod i-times mo na siya, i-minus pod sila, kung si answer di ba 0 pod, that is why ma-cancel na siya. That is why also ito na lang yung iwan. Again, F2 minus F1 na lang yung maiwan. Kaya pag ano na to sa class, i-distribute minus 0 pa din yung result. That is why in this problem, this will be the formula nating gagamitin to get the temperature change. Again, this is the formula to solve for the temperature change. Now, sir, ito yung formula pag Kelvin ang temperature change to Fahrenheit. what if baliktad? Yan. What if change of Fahrenheit to Kelvin? So the formula, baliktarin lang natin, it's 9/5. Change of Kelvin. Okay, baliktarin lang yung formula. Okay, so again, these two formula, ito yung gagamitin natin, no, to solve for the temperature change. But it depends on the given. Okay, it depends on the given. So in this problem, yes, na-derive na nato ang formula, na-derive na nato, ito yung formula natin gagamitin. Let's solve. Let's identify the given first. So you have left a can of soda in the freezer until it reached a temperature drop of 10 Kelvin. So we have here, the change in Kelvin is -10. Nag-drop man, baba, 10. Hala sir, di ba engon ka sir, kaya walay negative na value sa Kelvin? Yes, that's correct. There's no such negative thing na negative value for Kelvin. But in this situation, this -10 Kelvin here, that is the difference, now the change of Kelvin already. From its original temperature, nag-drop siya by 10 Kelvin. That's the temperature change in Kelvin. Again ha, technically, wala talagang value na negative for Kelvin because the minimum possible value for Kelvin is 0. But in this situation, in this problem, it was stated kasi na drop of 10 Kelvin. So there is a temperature change in Kelvin. Again, there is a temperature change in Kelvin and it dropped by 10 Kelvin. So negative yung ating value for the temperature change. Okay lang magka-negative ang value ng temperature change. Ibig sabihin yan, class, no? Pag negative ang value ng temperature change, mas malaki ang first temperature kesa sa second temperature. Okay? So we are going to solve the temperature change in the soda in Fahrenheit. So in this situation, ang gagamitin natin na formula is ito. Ito yung gagamitin natin na formula kasi in Fahrenheit man daw. So ganito lang. So i-substitute lang natin, class. I-substitute lang po natin. It's 9/5 times -10. Ilan, sir? Okay, very good. The answer is negative. Ayaw kalimutan sigfig. -18. Yes. Okay, that is our temperature change. Again, that is our temperature change. So, dili na kayo siya lisod ha. I-solve kay giderive na nako ang formula. Okay? Giderive na ako ang formula. Yeah. That's the, again ha, the temperature change in degree Fahrenheit is 18 degrees. -18. So again, class ha, yung negative natin na Kelvin, hindi siya ibig sabihin na value talaga ng Kelvin. That's the difference between two temperatures in Kelvin. Okay? Kasi again, walang negative value ang Kelvin na temperature. The minimum, the least possible is 0. Okay, 0. Sige, kindly take a picture of this one before let's proceed to the next example. Pangutana before we will end. Pangutana. Yes, that's correct, Cristiano. Pag ganito ang situation, pag change in temperature in Kelvin to Fahrenheit, yan yung gagamitin na formula. But wait, we have this kind of example. But wait, let's have this kind of example. What if ganito siya? What if Yes, Gabisan. Yes, Kiara. Kasi kung pag walang word na drop, ibig sabihin, hindi siya negative 10. But class, the direction must be clearly stated para hindi kayo malito. Again ha, the direction must be clearly stated para hindi kayo malito. So let's proceed. Ito. I want you to think. Okay? I want you to think. Kung saan siya pag-solve. Yeah, I want you to think. Go. Yes, Kim. Yes. Okay, let's solve this one. Actually, sayon radyo siya kaayo ang answer ni class. Actually, yes, sayon radyo siya kaayo. Para marasabi, sir, na sayon. Okay. So calculate the temperature change in the same can of soda in degrees Celsius. Kanina, 10 Kelvin pa rin to Fahrenheit, but this time it's Kelvin to Celsius. So again, let's recall the formula of Kelvin. It's degrees Celsius plus 273.15 degrees. Yan. So actually, pwede diretso. It's Kelvin 1. Yeah. It's Kelvin 1 is equal to degrees Celsius 1. Ay, sorry, 2 pala. 2 pala yung mauna. Sorry, 2. 2 yung una. 2. Yeah, unahang dako. 273.15. Then, Kelvin 1 is equal to degrees Celsius 1. Yan. Then, sa next step, temperature change man. Temperature change, minus. So, that's already, yan, change of Kelvin is equal to C2 minus degrees Celsius 1, which is equivalent also to change in degree Celsius. Yan. Again, wala naman 273 minus 15 minus 273.15, di ba? Zero naman siya. So ito yung mangyayari. So to calculate the temperature change in the same soda can, in the same can of soda rather in degrees Celsius, so kanina, the given, the temperature change in Kelvin is negative 10. degrees, ibig sabihin also, the temperature change in Celsius is equivalent to -10 also. Same lang. Okay? Same lang sila. Again parehas lang. Kung Kelvin to Celsius. Again the same lang ang temperature change pag Kelvin to Celsius. Yan. Question. Again wala lang. Ano lang siya kadali. Pangutana. So, walay pangutana. Let's proceed to this one. I think ma-answer na ninyo siya. Again, ma-answer na ninyo. So, calculate at which temperature a Celsius and a Fahrenheit thermometer will agree with one another. Kailan gayon? Mag-equal ang temperature na Celsius at saka Fahrenheit? At what value? Mag-equal sila? Class? At what value? Okay, very good. Naan na ganina ha, ipakita na nako to sa to naka-graph. It's -40. Again, it's -40. So if your degree Celsius is -40, it's the same value also of your degree Fahrenheit. As well as if degree Fahrenheit is -40, also the degree Celsius also is -40. Again ha, kailan mag-equal ang value ni Celsius at saka ni Fahrenheit? The answer is -40. Sir, can you show to us the solution na mag-40 sila? Yes, I can provide the solution. Again, I can provide the solution. Now let's have the formula. Of course, degree Celsius is equal to degree it's 9/5. It's 9/5 times degree Fahrenheit minus 32. Kung degree Fahrenheit naman, it's 9/5 degree Celsius plus 32. Okay? Again, alam yung point natin, both sila equal, no? Kailan mag-i-equal ang dalawa? Kailan nga ba? That's the question. So, sir, saan man na pag-solve? So, ingani pag-manipulate, no? Ingani siya pag-solve class. Please observe para makabalo mo no nga kailan nga ba? Now, take note class, take note. I-take note of this one. Let x, no? The x daw, let x lang, let's assume, let's have a value. X is equal to degree Fahrenheit is equal to degree Celsius. Again, that's the point kasi, kailan nga ba sila mag-equal? So let x be the value of degree Fahrenheit, which is equal also to degree Celsius. So let's solve using this one. Kaya dali man nga formula, oh. Again, let's solve kanina formula, kaya dali ra siya. Let's have this one. Okay, let's have this one. Kaya dali ra nga formula kanina. So ang degree Fahrenheit is x. Ang 9/5, yan, x plus 32. So we have here x minus 9/5x is equal to 32. Pila answer ani class? X over 9/5. X minus 10/5x. Pila ang answer? And let's have na lang this one para mas dali. X is minus 1.8x. I-decimal na lang nato kaya basig mas stress mo. So that is negative 0.8x. And to solve for x, yes, to solve for x, you are going to divide both sides by negative 0.8. Ay, sorry. Nasulat naman sa pikas. Divide both sides by 0.8. Yan. So x is negative, negative 40. So this is one of the process, no? Again, this is the one of the process class. Yan. So negative 40 degrees is equal to degree Fahrenheit is equal to degree Celsius. Okay? That's the time mag-equal yung dalawa ng Fahrenheit at saka ng Celsius. Okay, huwag nyo kalimutan yan. Dako ka na sa chance nga magawas na siya. Kanos sila mag-equal pag negative 40. So, pwede na mo mag-solve because you have the idea already na pag negative 40 degrees Celsius, equal siya sa negative 40 Fahrenheit. Pero if kinahanglan ang solusyon, well, nga ang process. And for your assignment, this one, yan. Again, for your assignment, okay? Again, for your assignment, I want you to solve that one. Ayan yung assignment ninyo ha. Ayan yung assignment. Okay? So, yes, that would be all for the part 1 of our discussion. Wait lang. Napicturean to Kim. Napicturean to Kim.